Hello, in this video I'm going to look at ordered pairs. So whenever we look at an ordered pair, essentially we consider them in terms of, like where you have a value. In this case, like we could have parentheses x comma y. And in any case, the x is always going to be along what we call the x-axis, and then we have that the y is going to be somewhere along the y-axis in either case. Now, notice that in this picture right here, you have 2 comma 3. Now, what that means is that you are 2 units away from the y-axis, so you count it 1 and 2. And then notice that it says 3, so what do? You count 1, 2, and 3. Now, normally though, for example, we might actually say that, we want to call it a name, for example, and, it doesn't really matter. You can say p parentheses x comma y, and this would be considered also an ordered pair. Now, whenever we talk about, let's say, for example, that you want to draw the axes, well, in some cases, you might actually label each of the quadrants respectively as, you have quadrant 1, and then you have quadrant 2, and then you have quadrant 3, and then you have quadrant 4. Now, in either case, this is always going to be the same no matter which course that you are in, like whether it's college algebra, trigonometry, or even calculus, because it's always labeled in this case as quadrant 1, 2, 3, and 4. So like if, for example, you have that, one of the x's is negative and you have that the other y is negative, then in that case you could say like, okay, well then yeah, we're in quadrant 3. So in either case, just remember that it's sort of not exactly left to right, but it goes 1, 2, 3, 4, or you could think of it in terms of counterclockwise. Now, in either case, one thing that we do with an ordered pair is that we might, try to graph, for example, an ordered pair such as like if we had, okay, let's look at the point 1 comma 2, and then maybe we can look at the ordered pair, let's say like maybe 3 comma 4. Then in that case we can actually look at that and see what that looks like. Let me see if I can try to expand this a little, and that way we can go ahead and plot these respectively. So we'll go ahead and use this so that we can see it. Okay, so 1, 2. Where is 1, 2 going to be? It's going to be right there, so we'll just notate that. We'll have to use a bigger font. Okay. So we'll have this right here, 1, 2. And then 3, 4, well, 3, 4 is going to be right here, right? So we have that this is going to be 3, 4. Okay. Now, notice that in either case, we could probably look at the line that joins these 3 points actually, right? So for example, like we could look at going from here and then to here, and maybe we can, we don't need to be precise in actuality. If we want to, make sure that we can form a solid line, then, maybe we can just use red, for example. And we'll just, draw as best as possible a straight line, right? So here, I have that I joined these 2 points, right? Now, respectively, maybe I should have called these points different letters. In either case, like maybe we could probably just call it, maybe the 1, 2 is Q. And yeah, we'll change the font for that one. Okay, so we'll say that this one is Q and this one is R. Now, notice that with 1, 2, that's going to be the point Q, right? So we have that that's Q. But what is 2, 3? 2, 3, we don't really have a name for it, but we went ahead and labeled 3, 4 respectively as R. Now if we wanted to, we could call 2, 3 also Q, not Q, but P. So we have the segments PQ and PR. And, you know, our goal will essentially be such that we can probably, you know, like find the distance from these points on. Because notice that if we were to look even further into the, you know, distance from Q to R, we could probably say, well, in order to do that, well, we need to form a right triangle. So we'll just form a right triangle right here, and then right here. And then how are we going to find the distance from Q to R? Well, basically that means that we would need to find that the distance from Q to R, because if I was to project it in the, you know, like just get like a projection, we can make it a little shorter. To get the projection, basically I have that, you know, this distance right here is from Q, and then I have that it's to R. But, you know, how do we find the distance from Q to R? Well, the answer is actually by Pythagorean Theorem, because you have that this is going to be A, this is B, and this is C. So essentially, Pythagorean Theorem says that A squared plus B squared is equal to C squared. So in our next video, we're going to look at finding the distance from two ordered pairs. And already now you know how to do it. It's by using Pythagorean Theorem. But then the question becomes, how do you get the distance, you know, like for the x's, and how do you get the distances for the y's in either case? And we'll show that.